Welcome. I'd like to welcome everyone to the Sunday morning sessions for Lightning Talks at PyCon. We're going to get started because we have quite a full selection this morning. So we're going to kick things off with Larry Hastings with Things You Don't Know.
That's a dirty lie. I'm giving my other talk. It's called Go With the Grain of the Pickle. That's what you get Sunday morning at 8:30. Okay, so ladies and gentlemen, this is a quick talk about how to use Pickle in your own projects. There are three binary serialization protocols built into Python: Pickle, Marshall, and Shelve. Of those, you don't want to use Marshall. That's really for Python's internal use. It changes with every version just about. It's not as flexible as Pickle. And Shelve is really Pickle using a database backend rather than just using a file, so you're not really gaining anything there. So you should use Pickle. However, Pickle will solve your problem for you, but it has its own way of working, and you kind of have to mold your program around it a little bit. And this talk is just to go over the things that I learned doing that with my own project. My project, very quickly, is it's called Meal.py. It's an implementation of a popular card game in Python, Python 3 actually, and I wanted to automatically save and restore its own internal state. So my first surprise is that init is not run on an unpickled object. Conceptually, this kind of makes sense. It's like you already created that object. It was just in another process a while ago, and we're reconstituting it out of data on the disk, but we're not initializing it. It's not a new object. So no, your init is not run. Which means that if you want to change your representation at all, you have a little bit of a problem if you want to have new members with new defaults. So you can't put them in your init anymore. What you really have to do is put them in the class as defaults, and this means that they have to be static. If you want to have something that's like a new empty list or a new empty dict or something, then you have a little bit of work to do. You're going to have your own dunder pickle or something. Surprise number two, your dunder new is run because we are creating the we're allocating the memory for the object. We're just not initializing a new object. So if you have some clever thing that you want to do inside of new, it'll still work. What I did specifically was I had objects that I wanted to make sure were singletons, and I just, instead of creating them only once, because now they could be created once and created from Pickle, I just made sure that they were singletons inside of new, and it worked great. Surprise number three, all pickled classes must be at module scope and must be consistently named. By consistently named, I mean that Pickle, the way that it reconstitutes your object is it's written down the name of your class inside of the Pickle file, and when you reconstitute the object, it goes into the module and says, let's find the attribute at top level with the name of the class. If you don't have one, because you had an inner class or something like that, then Pickle can't reconstitute the object. It can't find your dunder new, it can't find your class, it can't work. So this means you can't use inner classes, which is something I like to do. And you can't do anything funny like calling type to create new types at runtime because it kind of can't find them. Surprise number four, separate calls to pickle.dump do not share references. Everybody knows that Pickle is quite smart about saving multiple references to a single object and reconstituting that correctly so that you only have one object rather than 4 copies. However, that's only true inside of a single call to pickle.dump because it keeps a dictionary of all of the objects that it's seen so far, and when pickle.dump is done, it throws it away. It's a stack variable. So I had problems where I had aliasing. I had 3 copies of the player object or something like that. And the solution for this was, instead of making 3 separate calls to pickle.dump A, B, and C, I made one single dict, and I put all of my top level objects in that, and that encompassed my entire graph of objects that I wanted saved and restored. And actually, this thing on the right, that is exactly what I recommend you do, which probably would have saved us a lot of time, but I wanted to take the whole 5 minutes. Thanks very much.
All right, thank you very much, Larry. Next up is Peter Rank talking about ggplot.
In Python.
In Python.
Hi everyone, thank you very much for coming to my talk. I'm Peter Wang, I'm president of Continuum Analytics, and my bailiwick is visualization, interactive visualization, and dealing with large data analysis. And one of the current problems right now with Python for data analysis is that the plotting tools are not very well suited for it. The leading statistical analysis open source software, I think, is R at this point in time, and one of their key features is a plotting library known as ggplot, which just innately understands statistical data and has a lot of built-ins for easily looking at statistical data. So I want to address this problem. I'm actually the author of Chaco, which is a plotting library I built when I was at Enthought, and now Enthought maintains that library, and it is an excellent tool for doing interactive visualization. However, it needs kind of wrappers around it to make it work better for doing statistical sort of things. So just last week it occurred to me this would be a good idea. So I created a new project called Bokeh, which is really just some wrappers around Chaco to make it easier to do ggplot style plotting in Python. Where's Wes? Wes over there, he's the author of Pandas. Some of you may have gone to the Pandas talks at PyCon and seen the power that it has for data analysis and kind of statistical exploration. And so this is meant to work really well with that. So here's an example in Python. Basically, we're importing functional plotting commands from Bokeh. I'm calling the library Bokeh. And we're going to read a CSV file using Pandas, and then we're going to call ggplot on it. We're going to set the aesthetics. How many people here are familiar with ggplot or R? Okay. Not very many. So this spelling here is basically identical to how it would look in R. It may look a little funky for any of you that are object-oriented programmers, but it works for the statisticians. So what I'll go ahead and do here is actually do it this way. And this gives you a nice little plot. So that works. But this plot is not that interesting. We're going to go ahead and show off. Basically, you can do some additional things with it. You can configure by passing in, attributes. You can add additional kinds of what they call aesthetics or geometry to the plot. So here we actually have created two windows. We call ggplot twice. One is red, one is green. And to the green one here, I believe that one's called U. We're going to go ahead and add a geom line. And that is added. The line. It doesn't look that great, but you can kind of see it's all there. The actual visuals and the configuration, those things that's one of the nice things about ggplot. And we basically have to copy/steal all of those parameters and put them into this new tool. But the tool is flexible enough to support those things because it's built on Chaco. One of the implications of being built on Chaco is that you can interactively, you can do tools modularly and add these things dynamically to plots. So here, for example, let me actually show you the code for that. I created one plot, and then I'm going to add this regression tool. And this is not standard in ggplot, but it's something we can do. It's a very lightweight wrapper around some tools that are already available in Chaco. And some of you who've come by the Continuum Analytics booth may have seen me demoing some of these things. So here is a regression lasso, real time on data. And so likewise, it's very easy to add then things like linked brushing between different plots and the like. This has panning and zooming. And then some of the things that we still have to add are faceting, which is having an array of multiple plots in one image. But that is all capability that's actually already available in Chaco. This demo will sort of show. This is kind of the faceting, some of the faceting that's available, real-time updates, streaming data, we can handle it, and we can actually interact with the data regions and pan and zoom in them and do various other things. We can even actually move these plots around and reconfigure them. So this is all pretty straightforward stuff with Chaco. Here's something that you guys may have seen in our booth, which is a real-time spectrum analyzer demo that's showing a spectrograph of the FFT as I'm talking. This is already existing in Chaco. I simply have to put wrappers around this and expose it in ggplot. So you can imagine doing ggplot style commands in Python on real-time streaming data and having it come up like this. So this is what's ahead. Right now, the stuff is very, very just in its nascent stages, but if you want to get in touch with me, you you can contact me. I set up a mailing list at libralist.com, and you guys can sign up for that to follow the project. The one last thing, and one more thing, what we have is we have started working on exporting Choco, which is a pure Python sort of thing, exporting Choco to D3 so it works on the web. What this is showing is a Choco plot implementation of the Anderson-Flowers plot, and we're basically exporting it into the browser. Here it is loading up as an HTML in the browser. And furthermore, the brushing and selection is live in the browser using the facilities that are available in D3. This also will show that when you go and resize the plot, you see we've resized the plot in the window and exported, and it saves that sizing information in the export. Thank you very much.
Thank you, Peter. Next up is Mike Mueller, who will be speaking about PyCon DE.
Good morning, everybody. Supposed to be up. Good morning. Since we are at the Python conference, I would like to talk about PyCon DE. So that's, I see a different screen that's up here. Yeah, but I don't. Oh yeah. Okay. Good. Okay. I would like to talk about to you PyCon DE. PyCon DE, it's a Python PyCon version, the German PyCon. So as soon as we have this up, it makes it easier. Okay. Okay. Sorry, it worked before. Control. So, PyCon DE is a German. This year we have the second edition of this conference, PyCon DE, and DE doesn't really stand for Germany. It stands for the German-speaking Python community. So last year we had our first conference, and it was a great conference. We had about 200 people coming. We had more than 50 talks, 3 keynotes, 13 tutorials, and everybody had a great time, as you can see on this photo. And we would like to repeat this year. So this year, PyCon DE 2012 will be end of October, beginning of November. The same location as we had last year in Leipzig. And this was great. Everybody said it was great, and I hope this year people are coming, and a few more coming than last time. So if you would like to come, we have 1 day of tutorials again, 3-day talks, and 2 days of bar camp. It's a kind of unconference thing, and sprints. And this is a location there in Leipzig. It's a Cubus, which was a very nice conference location. So we had a lot of fun. We had a lot of talks and a lot of socializing there. So it's designed. Everything's pretty much in German. So, but if you like to, you can give a talk in English. It's allowed. But the main thing is to bring together the German people. So if you know anybody who would be interested in coming, just tell them that we have a PyCon DE this year, and that. The call for talks will be up soon, so you can give a talk, give a tutorial, and things like this. And also, if you like to sponsor, last year we had quite a few sponsors. So if you would like to reach the German-speaking Python community, then this might be your chance. So if you have, every sponsor gets a booth, and we have a job board. So if you like to, if you look for people in Europe, especially in Germany, that might be a way to go. This would be PyCon DE Germany, and I think I still have a minute. So I have yet another thing to announce, and this would be EuroSciPy 2012. This is the 5th edition of the European Conference for Science in Python. This will be in Brussels. That has been twice in Leipzig, twice in Paris, and now it moved to Brussels. A very successful conference. Also about 200 people, and if you're interested in scientific topics in Python and you're in Europe, that might be a way to go. So the submission deadline for a talk would be the 30th of April. So you see there's something going on in Europe. If you feel like traveling there, you are welcome. Thank you very much.
All right, thank you very much, Mike. Now, please welcome me in joining Carl Meyer.
Thank you. Good morning, PyCon. We're going to start with a brief quiz. The quiz is, what is that? Yell it out if you know. That is virtualenv. That is the portion of the Python standard library that virtualenv has to link into every virtualenv on your system in order to bootstrap its startup. If you use virtualenv, you probably have quite a few of these directories hanging out on your system. So let me introduce the unofficial motto of the virtualenv maintenance team. The only reason that we have functional virtualenvs in Python is because Ian Bicking and Philip Eby are mad geniuses. But most of us are not mad geniuses, which is why we're working on the new virtualenv, which we hope will be included in Python 3.3. And this is what a virtualenv looks like in the new virtualenv, which we're calling venv or pyvenv. You can see it's very clean. This is the entire directory structure. We have a scripts or a bin directory and a lib directory with site packages, no portion of the standard library linked or copied in, and an actual configuration file so that the configuration of your virtualenv is actually inspectable and makes sense. You can see what the home Python installation is, and you can just change true to false if you want to change whether the system site packages are available from your virtualenv. So the reason I'm up here talking about this is because this hasn't been merged into the Python 3.3 code base yet. I'm hoping that it will be before Python 3.3 is released. But first we need you all to help us break it so that we can fix it, hopefully. The implementation that we have is almost entirely thanks to Vinay Sajip, and it works very well. But there's a lot of edge cases we haven't had a chance to test yet or don't have the right setup for testing. So if you can download the reference implementation and try installing things in it and let us know what breaks, that would help us. It's PEP 405. I'm sure you can find that in your favorite search engine. And we hope it'll be coming soon to a Python near you. Thank you.
All right, next up we have Ian Oswald.
Good morning, everyone. So my name is Ian Oswald. I'm over from the UK. I taught high-performance computing a couple of days ago. I work with high-performance computing systems and a lot of scientific systems. I've spent a lot of years figuring out how to make my Python code run faster than just in regular Python. So I'm going to give you a super quick summary and some take-homes from the tutorial I ran a couple of days ago. Here we're seeing a Mandelbrot plot being prepared. It's running in pure Python. It's a bit slow. It takes about 16 seconds or so on this laptop without being plugged into the power. And it's a nice plot. It's a fairly meaty problem, 2 in the loops, and a fairly good resolution. Now, being a good computer scientist, I'm lazy. I really want the easiest way to get the speed-ups that let me get on with the rest of my life rather than messing around with the code. And we've heard a lot about PyPy this weekend, so PyPy on a bunch of my projects is really nice if we're not using NumPy, although NumPy support is coming in. Here I get a straight 10 times speed up, no code modifications. You just run PyPy on the original code and we get a 10 times speed up. And that's kind of cool. The fact that there's no modifications, that's wonderful. That means the code is correct. I can rely upon the tests, and I can just look at the speed improvements. Now, another obvious step forward would be to use Cython, where we can compile the code down straight to machine code. This requires annotations. It takes about an hour to teach it when I was teaching a few days ago. After teaching Cython, I then teach the other way of doing it using Shedskin, and I'm just going to show you the result. So with Shedskin, I've turned off the graphical output. Here we get a 50 times speed up. Shedskin takes your plain Python code, and for the modules it supports, it generates C++ code, compiles it, and gives you an exe. Or it can give you a .so module, which you can just import into your regular code. So for no code modifications again, you just run Shedskin, and then you run make, runs on Windows, and then you get an SO or an exe, and you just import it and run it. You get, well, in this case, a 50 times speed up. And that's really nice. So now we're getting kind of maximal performance for math-bound tasks on a single CPU on one machine. Now the final example I'm going to show you. So going back to Cython, I've got an 8-core machine here, 4 real cores and 4 virtual cores. I don't want to use just the one core, I want to use all of the cores, and we're going to see more cores on more machines in the future. So using NumPy, we can get behind the GIL, so we can turn off the global interpreter lock, and we can ask all of the threads using OpenMP to work in parallel. And that means that we get the result in a fraction of a second. On power, thank you very much. So when plugged into the mains, there I get 0.04 seconds. That's a 297 times speed up over straight Python. Now this result is the one that takes a little bit of work. This requires integrating NumPy into your Cython, and then the not massive step of changing for something in range to for something in P range, the parallel range operator, and passing in the keyword no GIL equals true, which turns off the GIL. At that point, it can auto vectorize over many cores for you using OpenMP. You've got a choice of schedulers, you've got a choice of some of the primitives from OpenMP. It takes another hour or so, so if you were to do that from scratch, you might spend half a day to a day learning it, but then you get a 300 times speed up, and it works across all of the cores on your machine. There are plenty of other options. I've got a summary of my talk online and a 55-page PDF that'll be updated. I gave it at EuroPython, I'll update it again. And that includes things like parallel Python and multiprocessing to go across machines. Thank you very much.
All right, thank you very much, Ian. Next up is Dan Frank talking about async DynamoDB.
All right, thanks, guys. All right, good morning, everybody. This is Async Dynamo. This is something that we built at Bitly and released open source in the last week or so. So back in January, Amazon announced this DynamoDB service, which purportedly they had been using internally and then just released to the public. It's supposed to be SSD-backed, highly available, fault-tolerant database. So we thought, great, let's build something with it tomorrow. So you guys recognize this guy? This is Werner Vogels. He's the Amazon CTO. And he actually offered to give out some back rubs if we built anything with DynamoDB. It happened. You guys know Hillary Mason, our chief data scientist? She gave one of the keynotes last year. Anybody see that? I heard it was pretty good, but I was still writing Java back then, so I didn't get to see it. Anyway, purportedly, she intercepted these back rubs somewhere in Germany. I don't know if there's photos of that or whatever, but I haven't raised this with her, but she didn't do any work on this, but got all the back rubs. Anyway, so we wanted to get started with this, and sure, HTTP, let's just fire off some requests, right? Get started? Yeah, not so much. So this is a hosted database service, of course, so you need to have some authentication baked in. Your firewalls aren't going to do the trick. So with Amazon, that means signing your requests. Some obscure, well, I don't know. The point is, one does not simply sign a request to Amazon. Well, like, you know, we could have done it, but, well, we probably would have ended up with this. So we didn't. You guys recognize this guy? This is Mitch Garnett. He's the maintainer of the Boto library for Python, which does a lot of great interaction with all the Amazon services. And so he went through the ordeal of setting that up. Problem is that when Boto makes requests, they block. So we had to come up with another way to make requests, which thankfully we already had. So we figured, all right, let's just put them together. So as a review, we need to take these Boto calls to signer requests and combine them with Tornado requests. But this is Python, so we can do it. Do whatever we want. We got something that looked like this, but it worked. So yeah, somebody just like deployed this without telling me one day, and it was working, so that was cool. Yeah, so it's pretty simple. There's no like greenlit magic going on underneath the scenes. You know, you instantiate stuff with your credentials, of course, define the callback, and then just act as though you're using regular Boto for the most part. So yeah, that's what we got. Hope some of you guys will use it, or maybe even help contribute. Thanks.
All right, next up, our final lightning talk for the session, Nathan Nurgler, who is speaking on Sphinx and HTML slides.
Good morning. So I spoke yesterday about Django Forms, and when I got notification that I'd been accepted, of course my first thought was, what am I going to talk about Django Forms, but then also, how am I going to talk about it? Because a friend of mine once pointed out to me that writing programs to help you write programs is more interesting than writing programs, and writing programs to help you write slides is more interesting than writing slides. So I thought I would write something that let me do restructured text, and because some of you will think I'm sick, I can stay in Emacs even longer and write my slides in restructured text. So I put together Hieroglyph, which basically cribs a few different things from the web to make these HTML5 slides. Because you're already writing your documentation using Sphinx, right? And you want to keep things in sync with each other, you want slides that look beautiful, and why not? So it's very simple. You simply add a hieroglyph as an extension to your Sphinx configuration, and then you can build your HTML5 slides. Make file information. It's really just, I guess I could show, well, so you write your document just like you normally would, first and second level. Headings become slides. There's some themes, there's CSS, there's incremental slides because that's very, very important. And there's also some directives to help you put stuff only in slides or not in slides, because if you want to generate both HTML documentation for handouts as well as the slides, you don't necessarily want your title slide images showing up. CSS, it's lovely. If there's themes, they're great. It's on GitHub. Thank you very much.
All right, thank you everyone for coming to our morning lightning talk session. We will have the opening address for the morning from Jesse Noller in a moment.